Alright, this will be the introduction for lab number 18. We'll be looking at thin lenses. So go ahead and click on this link right here and see where it takes you. And it's probably going to look a whole awful lot like this guy right over here. Let's just click on the begin button. And what we can kind of see is we can see an object, we can see a lens, and we can see an image. So let's go ahead and point these guys out. Right here we have the object, right here we have the lens, and right over here we have the image. What we can kind of do is we can measure the distances that we're interested in. So what we can do is we can say this is the distance to my object, so I'm going to call that distance to the object. This right over here is going to be distance from the image, and it's going to be this guy right over there. All of these guys kind of come off the lens. We can also see the focal length, and the focal length is going to be this guy right over here, and we can go ahead and measure this guy as well. One thing to bear in mind is the major tick marks are 10 centimeters, so what I could do is let's just go ahead and see what the focal length is. Pretty straightforward. It's going to be 10 centimeters and 20 centimeters. My distance to the object would be 10, 20, 30, 40, and then each one of these little guys is going to be 1, so we could say it would be about 44-ish, give or take. Now what we can do is we can let this thing run and see what happens to the distance to the object and the distance to the image as this simulation runs. So let me bring my cursor over here, and you can kind of see that the object is getting closer. We can pause it at several points, which I'm going to have you do, and record the distance to the object and the distance to the image. Please do so before it goes inside the focal length, because something important is going to happen, or better yet, do it before it goes off the screen. So here's what I'm going to have you do, is I'm just going to have you go ahead and draw this thing. Make sure that you draw a principal axis, which was that guy right over there. This guy right over here is going to be my lens. We can have the object and we can have the image. How do the rays go through the focal point? Remember, the focal point was that little dot right over there. Here I'm making it an X. I'll make it a dot, so you can see it a little bit better. Go ahead and sketch the rays. Do try to record some grid marks as well, because each simulation is going to be a little bit different, and that kind of tells me where you were. Is the image upright or flipped, and is image real or virtual? Well, flipped over is going to be this case right over there, and essentially any image that is over here is going to be what we would call a real image. If the image were to appear, say, over here, like when this guy moves inside of the focal length, then it's going to be a virtual image. So that guy would be virtual. I have you just go ahead and press the start button and observe what happens. Draw the setup outside and inside of the focal length, and think about a magnifying glass as you go ahead and do that. Then we're going to go ahead and take some data. And all I'm going to have you do is record the object distance and the image distance. I'm also going to have you record the height of the object and the height of the image. For this column right over here, don't write down what the focal length is, but we're going to go ahead and calculate that. So that guy is represented right here. I do have you record what the focal length is, and that's what you're going to record right here. So don't close the simulation, or you're going to have to redo it. It does change the focal length pretty much every time you pop this thing up. Then we're just going to use the thin lens equation, which is this guy right over there, to calculate what the focal length is. So we're going to fill this column out, boom, boom, and boom. Go ahead, take the average, and how close do you get? Lastly, I just have 3 quick little questions where we're trying to figure out where the object is, where the image is, and what the focal length is for a couple of objects, just to get some practice. Here I've given you a focal length. Here I tell you this is the distance to the object, and all we're trying to do is figure out where the image is. So what we would do is we would take the thin lens equation, and we would say, okay, well, I'm interested in the distance to the image, so I would say that 1 divided by the distance to the image should be equal to 1 over the focal length minus 1 over the distance to the object. And go ahead, plug the numbers in, and I just kind of mess around with you a little bit by giving you different focal lengths, different object distances, and image distances. Please just pay attention to what I've given you and what I'm asking for.